Right, our next section is for independent events. Independent events are when they don't impact each other. So when they're just independent, you just multiply the two probabilities together. So an example of that is number 4. It says, suppose that Pedro drives the same route to work on Monday through Friday. His route includes 1 traffic light. The probability that the light will be green is 0.42, yellow is 0.03, red is 0.55. What is the probability that the light is green on Monday and red on Tuesday? So what happens on Monday and what happens on Tuesday don't have an impact on each other. So we're just going to multiply the two together. So we've got 0.42 for the Monday, and we're multiplying that times the 0.55 for red on Tuesday. And just multiply those together, so 0.231. What's the probability that Pedro finds the red light on Monday through Friday? So Monday through Friday would mean Monday, Tuesday, Wednesday, Thursday, and Friday. He gets red every single time. So if that happens every single time, we're going to use the probability for red every time and multiply all of those together. So red all 5 days is the same thing as saying 0.55 to the 5th power, because there's 5 of them. So you could enter it into your calculator either this long way or this way. Either way, it should simplify down to 0.0503. Number 5, an airline estimates the probability a random selected call to its reservation phone line results in a reservation being made 0.32. Find the probability that none of the 4 randomly selected calls to the phone line results in a reservation. So this is make a reservation, right? So 0.32 is reservation made. If I take that away from 1, I get 0.68. So that would be reservation not made. So this is saying 4 randomly selected calls don't make a reservation. So that means 0.68 is happening 4 times. So I can either multiply it out 4 times or raise it to the 4th power, whichever way you want to do it, and you're going to get 0.214. Find the probability that all 4 randomly selected calls results in a reservation. So the reservation is happening. There's 4 of them, so we take 0.32 and raise it to the 4th, or multiply this by itself 4 times, and we get 0.0105. Okay, find the probability that at least one of the 4 randomly selected calls to the phone line results in a reservation. So if there's going to be at least one, it could be 1, it could be 2, it could be 3, it could be 4. So what we're going to do is we're going to subtract 1 minus the probability that no reservation happened. Okay, because at least 1 means there's more than no reservations. So when we did no reservations up here, it was 0.214. So we're going to say 1 minus 0.214, and that gives us 0.786.